In this video, I'll explain the concept of differentiation under the integral sign. Differentiation under the integral sign, it is the technique of evaluating definite integral of a function f of x comma alpha, where x is the independent variable and alpha is any parameter, and that value is evaluated using the rule called as Leibniz rule. So d by d alpha of integral from a to b f of x comma alpha with respect to x is given by integral from a to b dou by dou alpha of f of x comma alpha with respect to x, where a and b are constant. If the value of the limits is constant, then this is the formula to get the differentiation under the integral sign. If a and b are not constants, that means they are dependent on alpha. In that case, the value of this differentiation under integral sign is given by integral from a to b dou by dou alpha of f of x comma alpha with respect to x. This is the same plus here next two terms are db by d alpha into f of b comma alpha, that is replace that x by b and then x by a, that is upper limit minus lower limit, same way dA by d alpha of f of a comma alpha. Therefore, to evaluate any definite integral of a function of f of x comma alpha, we make use of Leibniz rule. So there are two formulae in Leibniz rule. One, when the limits of the integral are constants, when they are functions of alpha, there is another formula. So these two formulae you have to remember before working out any problem. Now let us consider one example to understand how to differentiate under integral sign using the Leibniz rule. The working rule I have written here, this is the given question: integral from 0 to 1 x power alpha minus 1 divided by log x with respect to x. I have to evaluate the value of this integral using the concept of differentiation under integral sign. So working rule to evaluate integral of a to b f of x comma alpha with respect to x is: first you have to take the given integral as phi of alpha, then differentiate this phi with respect to alpha, you will get phi dash of alpha. Then once again integrate phi dash of alpha with respect to alpha, that is, if you get phi dash of alpha as f of alpha, function of alpha, then phi of alpha you will get it as integral of f of alpha d alpha plus c. Now evaluate c by choosing suitable value for alpha and back substitute into this function phi of alpha to get the value of the integral phi of alpha. So let us apply the same procedure to this. So I will take the given integral, let phi of alpha is equal to integral from 0 to 1 x power alpha minus 1 divided by log x. You have to differentiate this with respect to alpha, that is applying Leibniz rule here, differentiating with respect to alpha on both sides, applying Leibniz rule to the right hand side. So you will get d phi by d alpha is equal to d by d alpha of integral from 0 to 1 x power alpha minus 1 divided by log x here with respect to x. So phi dash of alpha equal to, I'll write d phi by d alpha as phi dash of alpha. Now apply the Leibniz rule here. See the limits of the integration 0 to 1. So both are constant. They are independent of alpha. Therefore, you have to apply the first formula of Leibniz rule. So that is integral from 0 to 1 dou by dou alpha of this function x power alpha minus 1 by log x with respect to x. The meaning of this is you have to find out the partial derivative of this function with respect to alpha. Whenever you are finding the partial derivative with respect to alpha, the other variable x is kept as constant. Therefore, you will get this is equal to integral from 0 to 1 log x, 1 by log x is a constant. You take it outside. Then you have to find the partial derivative of x power alpha minus 1 with respect to alpha. So derivative of a power x is a power x into log a. So same method is applied here. This x is constant to the power some function. Therefore, its partial derivative is x to the power alpha into log of x. Anyway, derivative of 1 is 0 with respect to x. So this log x cancels. Hence, I'll get this equal to integral from 0 to 1 x power alpha into dx. Now, you have to get the value of this integral. So, x to the power n formula. What is the integral of x power n? X power n plus 1 divided by n plus 1. The limit is from 0 to 1. So, that is equal to, when you apply the limit, x equal to 1, 1 to the power alpha plus 1, 1 to the power any value is 1, 1 by alpha plus 1. Because the other value is 0, so it is 0. So upper limit minus lower limit is anyway 0. Therefore, you will get the value of a phi dash of alpha as 1 by alpha plus 1. So this is a function of alpha now. So second step over now. Third step is, after differentiating this with respect to alpha, now you have to integrate this with respect to alpha. So integrating with respect to alpha. So I'll get integral of phi dash of alpha with respect to alpha equal to integral of 1 by alpha plus 1 with respect to alpha. So this gives you phi of alpha equal to integral of, if you consider x here, so as per your standard formula, integral of 1 by x is log of x. So same here, log of alpha plus 1 plus some constant of integration c. So now to evaluate C, next step is to evaluate the value of C. So to evaluate C, I will make use of the first expression, that is phi of alpha equal to the value of this integral. So I will take alpha equal to 0 in equation 1. So I will get, when alpha equal to 0 here, x power 0, 1 minus 1, the whole value becomes equal to 0. So phi of alpha equal to 0. When alpha equal to 0, then phi of alpha equal to 0. The same value you have to apply here. So from this equation, you can name this as 2. Now, when alpha equal to 0 here, so phi of alpha I got it as 0 now. Log of alpha is 0 plus 1, log of 1 plus c. Okay, therefore log of 1 is 0, c equal to 0. The value of constant is c equal to 0 we obtained. Hence, that value you have to substitute here. You will get phi of alpha equal to log of alpha plus 1. Hence, the value of this integral is, I'll write here, phi of alpha is equal to log of alpha plus 1. So this is the required answer. This result is obtained using the Leibniz rule, that is differentiation under integral sign. Here the limits are constant values or they are independent of alpha. Now see the second problem. If phi of alpha equal to integral from 1 by alpha to root alpha sine of x square with respect to x, then you have to find the value of phi dash of 1. So first let us take phi of alpha as this. Phi of alpha equal to integral from 1 by alpha to root alpha sine of x square with respect to x. Here f of x comma alpha equal to sine of x square. Now this function contains only x here, but the limits are a function of alpha. Therefore, they are not constant, they are dependent on alpha. Hence, you have to apply the Leibniz rule. Differentiate with respect to alpha on both sides. So we'll get phi dash of alpha. So I have done this differentiation because I want to find out phi dash of 1. So phi dash of alpha is equal to d by d alpha of 1 by alpha to root alpha sine of x square with respect to x. Now for this you have to apply Leibniz rule because it is differentiation under integral sign, and in the Leibniz rule you have to apply the second formula because the limits are not constants now. Therefore 1 by alpha to square root of alpha dou by dou alpha of sine of x square with respect to x, this is the first term, plus d, the upper limit, root alpha by d alpha into f of alpha x is to be replaced by root alpha comma alpha minus the lower limit is d by d alpha of 1 by alpha into f of, replace x by 1 by alpha comma alpha. Hence you will get, see, when you find the partial derivative of this function with respect to alpha, it is 0 because this function doesn't contain alpha. So x is treated as constant when you are partially differentiating with respect to alpha. Therefore, sine of x square, this derivative with respect to alpha is 0. So therefore, whole term vanishes. You have to find the value of these two terms. So I will write here. So now derivative of root x with respect to x is 1 by 2 root x. So you will get 1 by 2 root alpha into f of root alpha comma alpha. In this function you have to replace x by root alpha. So root alpha whole square is alpha. Sine of alpha minus d by d alpha of 1 by alpha. Derivative of 1 by x is minus 1 by x square. So minus 1 by alpha square into, replace x by 1 by alpha in this function. Sine of 1 by alpha square. Now you have to find out, this is your phi dash of alpha. You have to find out phi dash of 1. Therefore put alpha is equal to 1. So 1 by 2 into sine of 1 minus 1 by alpha equal to 1, 1 square is 1. So into sine of 1 again. So simplify this gives you half into sine of 1 minus, here this value is 1, minus of minus plus 1 by 2 sine 1 plus sine of 1, that is equal to, when you add these two you will get 3 by 2 into sine of 1. This is the value of phi dash of 1. This value is evaluated using the concept of differentiation under integral sign using the second formula of Leibniz rule. This is how we apply the Leibniz rule in two different conditions. See, Leibniz rule can also be stated like this. If you have an integral from a to b f of x comma alpha, here it is with respect to alpha. So in the previous rule, it was with respect to x. So in this case, you have to take the given function, given integral as phi of x. Then phi dash of x is given by integral from a to b dou by dou x. Instead of alpha, you will get x now, f of x comma alpha with respect to alpha. So when a and b are constant, if a and b are not constants, they are functions of x, that means they are dependent on x, then the rule changes as dou by dou x of f of x comma alpha with respect to alpha plus d by dx of upper limit into f of x comma, replace alpha by b of x, and minus d of lower limit a of x by dx f of x comma, replace alpha by the lower limit. So in any way you can state, so if you have, it is with respect to x, the integral is with respect to x, then you have to take the given integral as function of alpha. Otherwise you have to take it as function of x. Accordingly you have to make changes in the formula of Leibniz rule. I hope you understood the concept. Thank you for watching.